Welcome back, everyone. We're continuing our discussion of the system AX equals B from the previous video. This is the exact same matrix. And we're going to be answering this question, which is very important for us, and that is which combination of the columns of A produces a particular vector B. So what we had so far were equations AX equals B, and we get those equations from over here. We have x1 equals b1, negative x1 plus x2 equals b2, and negative x2 plus x3 equals b3. These equations are called linear because the variables x1, x2, x3, or the unknowns x1, x2, x3 are to power 1. Similarly, for the answers, you're not getting x1 times x2, for example. You're not getting x1 squared or x2 squared. The only thing you have is really a linear combination of the three unknowns x1, x2, and x3, meaning they're multiplied by some numbers and added together. You will not see a more complicated expression, which is good news. That means it's easy to solve. Now from here, the solution looks like this. If it exists, it will be the inverse problem. So A inverse applied to B will give us X. We will, as the course progresses, describe ways for finding A inverse in a different way than how I will explain it here. But here, this problem is sufficiently easy that we can actually invert the problem. What are we trying to do here? Well, we're trying to find expressions for x1, x2, and x3 through b1, b2, and b3. The first equation here tells us exactly that x1 must be b1, right? Now, that means that we can replace here x1 with b1 and immediately from here find an expression for x2. So from here we have x2 must be b1 plus b2. Now we have found x2 and we can replace that in the third equation. So instead of x2 here, we have b1 plus b2. And we see that in fact x3 is given by b1 plus b2 plus b3. So it turns out that we have this inverse problem where if we know, so if b equals, for example, 0, 0, 0, then x from these equations over here will also have to be 0, 0, 0, right? We have some kind of a sum. If b equals 1, 3, 5, which we had in the previous video, then it turns out from the new formulas, we see that x1 is also b1, so that's 1. x2 is b1 plus b2, which is 1 plus 3. That equals 4. And x3 is the sum of all 3, so that's 1 plus 3 plus 5, which is 9. And we know this to be true because we actually had found this b in the previous video from x. Now, this new system, as I noted here, is an A inverse B equals X. So what is then A inverse B? How do we find A inverse in this particular problem? Well, observe here the columns. Let me show you in different columns. So here you have something multiplying B1. Then you have here column B2. And right here, we have column B3. So in fact, we can see the inverse matrix as follows. We have X, which is X1, X2, X3, equals B1 times this vector 1, 1, 1 plus b2 times the vector 0, 1, 1 plus b3 times the vector 0, 0, 1. From here, we can write the inverse matrix to be the matrix consisting of these three columns. So we have x equals the matrix 1, 1, 1, 0, 1, 1, 0, 0, 1 times the vector b1, b2, b3. Then this matrix is A inverse. Now it's true that for this system where we had A to be a matrix with some negative numbers, those were actually, we were given differences, to find A inverse, which is actually consisting of sums. And that somehow makes sense because the inverse to a difference is in fact a sum. Now, when we have this A inverse, we can use it to find any x given a b. So let's see how that will work. Let's say if we have the vector b, so equal to 1, 1, 1. Let's see what vector x it came from. We can use the A inverse matrix. From here, x equals 1, 1, 1, 0, 1, 1, 0, 0, 1 times the vector 1, 1, 1. Now, you can carry out this multiplication using dot product. So you would do the first row times b, the second row times b, the third row times b. But really how I would like you to see this is that this first coefficient, this first entry of b, or the first component of b, tells you how much of the first column of A you should take. The second column, entry of B tells us how much of the second column to take, and the third one tells us how much of the third column to take, so that we can add them up in the linear combination in the end. So actually this vector 1, 1, 1 simply tells me to add up the three columns and I get my result. So I know that I have 1, 2, 3 for x. Now let's look at the inverse, I suppose the forward problem. If we had this x, how to find this b, just one more time with matrix multiplication. So we know that b equals A times x, which is the matrix 1, negative 1, 0, 0, 1, negative 1, 0, 0, 1, multiplied by the vector 1, 2, 3. Now, similarly to the previous situation, the previous multiplication, this tells us to take once, or 1 times the first column. The second entry tells us to take 2 times the second column. And the third one tells us to take 3 times of the third column and add them up. So for the first component of the answer, you see that only the first column plays a role because the second and the third have zeros there. So I know that the first answer or the first entry must be 1. Now for the second one, I have negative 1 from the first column plus 2 from the second column because 2 multiplies the second column, and that gives me a 1. And then I know that, well, the first column doesn't really play a role in the third component because it has a 0 there. So I have 2 times negative 1, which is negative 2, plus 3, that gives me a 1. So I carried out this multiplication as a linear combination of the columns rather than row times column multiplication. Now, of course, you could do that as well. You could use dot products to compute these numbers. But in this course, really, we're going to be looking at the linear combinations of columns of matrices. Okay, more on this in the next video.